This video is about using Ansible to create network device configurations from templates. It can also serve as a first step down an organization's path towards network automation. First, I'll briefly describe what Ansible is. Then I'll start with a demonstration of the setup used in this video. After the quick demo, I'll step back and show a high-level picture of three main pieces that make this work. Then I'll dive into these three parts in detail using the demo example as a guide. I'll wrap up with a fast review to help these ideas stick. For reference, I've uploaded the setup used in this video to GitHub, and I've included a link to that in the video description. If you want, you can use that to follow along. This video is inspired by Kirk Byers' Python for Network Engineers blog. On Kirk's blog, the same topic is covered with just a slightly different implementation. Kirk hosts a network automation meetup in San Francisco and also runs a Python for Network Engineers class. Also, this video depends on Ansible, Jinja 2, and YAML. In this video, I'll include an introduction to all three. Links to more information on these areas is in the video description. What is Ansible? Ansible is an IT automation tool used in server deployments. It is similar in function or purpose to tools like Puppet, Chef, and SaltStack. Ansible is open source and free to use. It is written in Python, but Python development skills are not required to use it. Ansible is agentless, meaning there is no Ansible client to install and target nodes. By default, Ansible runs over OpenSSH and utilizes Python installed in target nodes. Of course, on network devices, Python often is not available. However, Ansible can be used with any device with an API, if a module has been written for that device. In this video, I have Ansible running in Ubuntu. Installing Ansible was as easy as running sudo apt-get install Ansible. The end result. I'll start by demonstrating the end result of this Ansible setup. For this example, we will imagine we're building out a leaf-spine network topology. To do this, we require configurations for many leaf switches. Keep in mind this is just an example, and the steps in this video can be applied to any kind of text configuration. There will be background work of setting up what's called an Ansible playbook and writing templates. I'll cover the details of this shortly. Once that is ready, we just need to edit a variables file with the details for each switch. Here is an introductory look at that file. In it, we can see parameters for each switch. For example, here is a switch that has a key hostname and a value of leaf01m. We also see parameters for this switch to cover things like its management IP, VLANs, and details about uplinks. There are 4 switches here, but we could add as many switches as we need configurations for. Once my parameters are set, all that needs to be done is to run what's called an Ansible playbook. I'll do that now. The playbook run has resulted in 4 configurations being output to /temp on my system. This is indicated by the keyword changed. Checking /temp reveals I have 4 files. Opening these files up reveals configurations I can apply to the new switches. Keep in mind these configurations are stripped down for the purposes of this video. Ansible playbooks are intended to be idempotent. This means if we run the same playbook again, nothing new will occur. Ansible recognizes the output configuration files are already present in /temp. Ansible will not overwrite a file if the correct one is already in place. However, if we change some variables and reran the playbook, Ansible would recognize the difference and overwrite the output files as needed. This video focuses on configuration from templates, but with Ansible I could extend this playbook to perform additional tasks. Perhaps, for example, to insert the new switch names into DNS, add the switches to monitoring systems, add them to inventory systems, and more. To understand how all of this works, I'll start with an overview of 3 main components in play here. High-level overview. For this example, I used 2 variable files. One of these I just showed a preview of. It holds details for individual switches. I could have used one variable file alone, but I chose to use a second global variable file as well. This file has variables with scope greater than individual switches for items like NTP server IPs and syslog server IPs. These variables are inserted into templates. For templates, Ansible uses the Jinja 2 language. Wrapped around the variables files and the templates is Ansible. Ansible abstracts complexities away from the end user. So for example, as I said, the templates are Jinja 2 formatted. Jinja 2 is a Python library with a Python API. However, no direct knowledge of the Python API is required because it is handled by Ansible. When the playbook is run, variables are inserted into the templates and the configurations are output. In our case, we have it set up to output to /temp. Now that we've had a look at the components, let's jump in and look at these pieces in more detail. Ansible directory structure. Directory structure is important in Ansible, especially when using Ansible roles as is done in this example. I'll walk through this now. Ansible.cfg is a configuration file where custom Ansible options can be set. This example doesn't need any custom options, so it'll just be the default one that comes with installing Ansible. Variables that apply to groups of hosts can be placed in the group vars directory. This example makes use of the all group, which applies to all hosts. Therefore, a file named all is here that we will look at later. Next is the hosts file, which I'll open now. This is an inventory file for Ansible, used to enumerate out hosts to target for server orchestration tasks. For our purposes, only the local system is used. Therefore, there is only a single line for localhost. Also, a host option is set. Normally, Ansible tries to connect via OpenSSH to a host, but there is no need for that here, so I have Ansible_connection equal local. The next directory is called roles. Ansible roles are an organizational construct. In the Ansible playbook, we will apply a role named tor. This keys Ansible off to the fact that it needs to look for a subdirectory named tor under the roles directory. For future roles, there could be other directories, like perhaps LB for load balancer and FW for firewall, whatever names we want. Under the tor directory are three subdirectories: tasks, templates, and vars. Tasks will hold instructions for when the tor role is used. In our case, this just means to generate configurations from templates. The templates directory holds the template file used in this video. The vars directory holds variables for the tor role. In our case, it's variables for switches. We saw a brief look at that file a moment ago. Finally, in the directory tree, there is templates.yml or YAML. This is the Ansible playbook that will be run to make everything stick together. I'll go further into the Ansible parts now, starting with this playbook I named templates.yml. Ansible files. In Ansible, instructions for actions to take are through what Ansible calls playbooks. I named my playbook templates.yml. This file is in YAML format, so it has the .yml extension on it. I'll open it up here. YAML's main goal is to be human readable, which can be seen here as it's pretty easy to look at and get an idea of what is being defined. YAML files start with a triple dash. There are two types of data constructs here: list items and key value pairs. List items are designated by a dash, a space, and the actual list item. Key value pairs are designated by a key, a colon, a space, and a value. Lists and key value pairs can nest inside one another. Correct indentation is critical when nesting items. The playbook here is very short with just a few instructions. There is just a single play designated by a list item dash and a space. Nested inside this list item is 4 key value pairs. The first key is name. The name is for readability and shows up in the output when the playbook is run. The main job of this play is simply to apply the tor role. Therefore I put apply tor role as the value. The next key is gather facts, which I have set to no. Gathering facts is very helpful for server orchestration, as Ansible will collect a lot of data about target hosts. This data is called Ansible facts and is held in variables that can be used in plays. However, this is unnecessary here, so it's disabled. The next key is hosts. This is needed so Ansible knows where the play is to be applied. Normally this would be to a group of hosts. However, in this demo, we are only generating configurations on the local system, therefore it says localhost here. This matches the host file we saw earlier that had a one-line entry for localhost. Finally is the application of a role I've named tor. What's important is that the name matches the directory structure. So if I called this role LB, then my folder here would need to be called LB as well. Since a role named tor is being used, Ansible checks for a file named main.yml under roles/tor/tasks. We do have this file here, and I'll open that up now. Again, we have a YAML formatted file. It starts with the triple dash. We have just a single list item again. This means just a single task is run. The task has 3 key value pairs underneath it. The first key is the name key again. This will provide a description for the task. In this case, I put generate configuration files. The next key is template. Template is the name of an Ansible core module. Ansible has hundreds of modules available for a wide range of purposes. These are described at docs.ansible.com. The parameters we pass to the template module are src for source and dest for destination. src describes the name of a template file to use. dest specifies where to output generated configuration files. Something new here is the double curly brackets. This is syntax used in the Jinja 2 templating language and means a variable is inserted where the brackets are. The values of these brackets will come from the Tor rule variables file, which we will look at next. The final key is called with_items, and the value is switches. This is an iterator. Ansible is going to find a key named switches in the Tor rule variables file. With_items tells Ansible to loop through the items under the key switches and to perform the action above, namely to generate config files for each switch from the specified template. One thing to note is we are working with template files and variables files, but there are no paths passed for those. Ansible is able to find our templates and variables because we are using a role named Tor, and we have a matching directory structure with a parent folder named Tor. Now let's look at those files. Variables files. In this demo I'm using two different files, one under the roles/tor/vars folder and one under the group_vars folder higher up. I'll open up the variables file for the Tor role first. It has the name main.yaml. This is a default name that Ansible knows to look for. Again, we see the triple dash at the top. Then at the top level is a key named switches. This links to the with_items key we saw in the Tor role task file a moment ago. Each individual switch is here as a list item. It's important that the indentations are aligned so it's clear what variables are part of what individual switch items. Let's look at the first switch. There is a key host name with a value leaf01m. Recall in the task there is a variable substitution for item.hostname. Therefore, for this switch, a file leaf01m.cfg will be generated. Here is a key named profile with a value of leaf. In the task, we said Ansible should look for a template based on item.profile as a variable. So in this case, item.profile will resolve to the string leaf. Ansible will therefore look for a template named leaf.j2. There is a key management_IP, mgmt_IP, which has a value of the switch's assigned IP address. This is an example of a value that will be inserted into the final output configuration. The city key has a value MIA. I'll use this to select NTP servers and syslog servers that are used for switches in the city Miami. Some other keys and values include VLANs and details about uplinks. For uplinks, there's a key named uplinks. The value is a 4-item list. Each list item represents a single link from the leaf switch to a spine switch. Each link has details used for the final configuration, including the interface used, the IP address for the interface, the connected spine switch name, and the spine switch port. Now we'll look at the other variables file I used. This YAML file is under the group_vars folder and is named all. All is the name of a group that applies to all hosts, so I can access these values from any role, including the Tor role I'm using in this video. Here I have a top-level key city. Under this key are two subkeys MIA and NYC. These represent Miami and New York City. Under these cities are keys for NTP servers and syslog servers. The key syslog_server is an example of a simple key value pair again. The NTP_servers key has a value that is a list of NTP server IPs. All of these variables here and in the main.yaml file we saw a moment ago are inserted into a template. We will look at that template now. Jinja 2 templates. Jinja 2 is a templating language for Python. I'll cover some basics of it here, including variable insertion and logic functions. Of course, much more about what you can do with this rich templating framework can be found in the official Jinja 2 documentation online. The template file is located under roles/tor/templates. In this demo, I just use one template, but we could have many templates to represent different models of switches and different configuration standards. There's a file here named leaf.j2. First, everything that is not in brackets will come out in the final config the same as it is here. Nothing will change. Next are variable insertions. These should look familiar because we saw them in the Ansible task earlier. Looking at the first line, there are double curly brackets here. The variable enclosed in these double brackets is item.hostname. This will get replaced with the value of the hostname key from each switch. Another example is item.management_p, mgmt_ip. This is another key from the variables file. On the second line, we see item.hostname again, but also a pipe and the keyword upper. This format is an example of a Jinja 2 filter. Here the filter is upper. All this means is to make the variable all uppercase in the output. Next is an example of a logic function in Jinja. Logic functions include if-then statements and for loops. Here is an example of a for loop. The loop has a start tag and an end tag. Both the start and end are enclosed in a bracket and a %sign. This for loop says for uplink in item.uplinks. If you recall, there was an uplinks key in the vars file with 4 list items representing interfaces. Therefore, this for loop will iterate through 4 times to generate individual configuration snippets for each port. Here is an example of the output. The end of the for loop is denoted with the end4 keyword, enclosed in the bracket and %sign again. Below this are more examples of for loops for VLANs, VLAN interfaces, and an OSPF section. Next is another for loop. This time we make use of both variables files. First we have to resolve item.city. This value is found with the switches variables. In this video this resolves to MIA. Once the city is resolved, Ansible looks for a hierarchy of keys: city, MIA, NTP_servers. This path is found in the group_vars all file. Looking at that file, we can follow down the keys: city, MIA, NTP servers. There we find a list of 4 items, which represent NTP server IPs. In the end, this loop results in a config piece that looks like this. The next line is similar to what was just covered, but without a for loop. That's because we are only using one syslog server destination IP. What's nice about this organization is if we wanted to change this config to be for a switch in New York City, we would just update the Tor variables file to point to NYC instead of MIA. Then a run of the playbook would point to the appropriate NTP and syslog servers for that city. The final construct here is an if-then-else statement. Again, we see the now familiar bracket and %sign enclosure. If the city of our current switch is MIA, then the message of the day becomes this. Otherwise, the message of the day will be this. So we have the if statement, an else clause, and the statement ends with the end if block. Final review. Now that we've seen all the pieces in detail, I'll do a final fast review. Before I jump to that, a quick plug for my channel. If you're interested in more videos on network automation, SDN, and more traditional network engineering topics, please subscribe to this channel. Also, I can be found at linkedin.com/in/David Mahler. If you stop by there to connect and say hello, that is really appreciated. Review. This video explored creating network configurations by templates in Ansible. First, the Ansible files. The playbook in this video I named templates.yml. This playbook is in YAML format. This playbook has a single list item. This means this block here represents a single Ansible play. The play has a few key value pairs: a descriptive name, disabling the collection of facts about nodes, specifying only the local host is involved in this play, and finally, applying a role named Tor. Due to the application of a role named Tor, Ansible checks under roles/tor/tasks for a file named main.yaml. Looking at this file again, there is a single task or instruction for the Tor role. A name is specified, then the template module is called. The parameters passed to the template module are where to find templates and where to place the generated configuration files. The double brackets are Jinja 2 language for variable insertion. The values of this variables come from looping or iterating through a key named switches. The switches key is located in roles/tor/vars in the file main.yaml. Under this key there were 4 list items for 4 switches, but there could have been many more. Each item has details for a single switch, including the name of the profile to use. The Ansible task specified to look for this key and to use the values as the name of the template. The other variable file I used was in the group_vars folder and named all. Here I placed some global variables for NTP server IPs and for syslog server IPs. Of course, much more could have been here. Finally, there's the template file leaf.j2. In the leaf.j2 template, there are variables designated by double brackets. Values are inserted based on the 2 variables files mentioned a moment ago. Then there are examples of for loops and an if-then-else statement in Jinja 2. That wraps up Ansible for template-based network configurations. I hope it was helpful.